Lesson 4-7, using the least common multiple or LCM. And in this lesson, you learn to find the least common multiple of two or more numbers and to compare fractions. Let's take a look at this example on astronomy. Some clear night, go to a park or out in the country and spend some time looking at the night sky. In ideal conditions, you'll be able to see about 2,500 stars. Although there are many more than this, some nights you will even be able to see some planets. The chart at the right shows the number of Earth years it takes for some of the planets to revolve around the Sun. In 1982, the planets Jupiter and Saturn were in conjunction. That is, they appeared very close to each other in the night sky. How often do these planets line up in these positions? And we will solve this, we'll answer this question in example 1. And let's take a look at this chart. Okay, obviously the Earth takes one Earth year to revolve around the Sun. Jupiter takes 12 Earth years to make one full revolution around the Sun. Saturn 30 Earth years around the Sun, and Uranus would be 84 Earth years. Okay, so when one year in Jupiter is equivalent to 12 Earth years. Okay, one Saturn year is equivalent to 30 Earth years, and so on and so forth. Okay, so let's take a look at how we are going to answer the question. Okay, first let's talk about a multiple. A multiple of a number is a product of that number and any whole number. Okay, so definition, you need to write this down in your notebook. A multiple of a number is a product of that number and any whole number. Let's recall that whole numbers are 0, 1, 2, 3, 4, 5, and so on and so forth. Okay, so when you talk about multiples of 2, okay, since the definition, a multiple of a number is a product of that number and any whole number. So when you say multiples of 2, when you multiply 2 by 0, you end up with 0. If you multiply 2 by 1, end up with 2. Multiply it by 2, end up with 4. 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, and so on and so forth. You get the idea. Definition of a multiple. So the multiples of 2 are 0, 2, 4, 6, 8, 10, 12, 20, dot, 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 means it goes on forever. Multiples of 5 the same way. Starts with 0, 5, 10, 15, 20, 25, 30, 35, 40, and so on and so forth. Okay? Now, multiples that are shared by 2 or more numbers are called common multiples. So in this case, some common multiples of 2 and 5 are 0, 10, and 20. Okay, they are in blue. So you have 0, 10, and 20 are the multiples. Okay, the least of the non-zero common multiples of two numbers is called the least common multiple of the numbers, or the LCM. The least common multiple of 2, 5, and 10 is obviously, okay, the least common multiple of 2 and 5, is 10, because that is the least non-zero common multiple of 2 and 5. Again, we're talking about the least non-zero common multiple. So in this case, the number is 10. Let's take a look at example, the top example, and see how we can solve that problem. How often will Jupiter and Saturn appear close in the sky? And letter B, when will this happen next? And letter C, how often do Saturn, Jupiter, and Uranus coincide? That means they're on the same line, and we see them very clearly in the night sky. Okay, so let's take a look at letter A. And according to the table, Jupiter revolves around the Sun every 12 Earth years and Saturn every 30 Earth years. The time required for the planets to coincide in this way again will be a multiple of 12 and 30. So this is a multiple LCM problem. Okay, let's list the multiples of 12, starting with 0. 0, 12, 24, 36, 48, and 60. And for 30, 0, 30, 60, 90, and 120. And if you notice, the least non-zero common multiple is 60. So the least common multiple of 12 and 30 is 60. Jupiter and Saturn coincide every 60 years. So you see them very close to each other in the night sky. every 60 years. Okay? And let's take a look at how to answer letter B. When will this happen next? Okay? So the last time Jupiter and Saturn coincided was 1982. The next time will be 82 plus 60, or 2042. So in 2042, okay, Saturn and Jupiter will coincide. Okay, and letter C, find the LCM of 12, 30, and 84 to find the number of years for Saturn, Jupiter, and Uranus to coincide in the same way. So we now have three numbers to look at instead of just two. Okay? And instead of listing, there's another method that we can use to find the LCM of numbers, and that's what we call prime factorization. Again, this is the same as finding the greatest common factor. So a common multiple of numbers contains all the prime factors of each number. So the LCM contains each factor of the greatest number of times it appears for any of the number. Okay? So, what do those sentences mean? Let's find out. The prime factorization of 12 is, okay, using a factor tree or the drop down method, obviously be 2 times 2 times 2. That's a prime factorization of 12. Prime factorization of 30 using the drop down method or the factor tree will be 2 times 3 times 5. And the prime factorization of 84 would be 2 times 2 times 3 times 7. Okay? So first, we'll do what we did during finding the GCF of numbers. We find the common factors. So this is a common factor for all three. Right there. Well, let me redo that. It's a weird circle. So this is the common, these are the common factor for all three numbers, 2. And if you notice, okay, if I ask you right now what the GCF of these three numbers is, the GCF is the common factor of all three, which is simply 2. But we're not looking for the GCF, we're looking for the LCM. So what do we do? Again, the LCM contains each factor of the greatest number of times it appears for any of the numbers. So what does that mean? It simply means this. Okay? Now if you notice, okay, 3 and 3 is common to these two numbers, 30 and 84. Even though it's not common to 12, we're trying to find the LCM, so we bring down the 3 ones. We also see that 2, put that in this color, okay, is common to 12 and 84. So this one, that 2 right there, they're both common, so we also bring it down once. Okay? And since it's saying the LCM contains each factor of the greatest number of times it appears in any of the numbers, it simply means that we simply have to bring down the rest of the prime factors. So you get that number, oopsie, bring it down once, that's a 2, we make that disappear again. Okay. There. Should it disappear? Nope, not yet. Okay, so it should disappear now. 12 and 30. Okay, here we are. Let me make the other stuff reappear. There you go. Okay, so we bring down the 2. And this one, we bring down the 5 as well. And we bring down the 7. Because it's saying the LCM contains all the prime factors of each number. Okay? So we multiply all of them. We end up with 2 times 2 times 3 times 2 times 5, which is 420. Okay? So that's 420. So what we'll do right now is, not that one. Okay. the LCM of 12, 30, and 84 will be 420. And then let me make this reappear. Okay. So we bring them down once. Okay, and that's what it's saying. Find the common factors, then multiply all of the factors using the common factors only once. So the answer would be 420. Jupiter, Saturn, and Uranus will coincide in this way every 420 years. Okay? Let's take a look at example number 2 and see how this is connected to algebra. LCM of 2 or more monomials is found in the same way as the LCM of 2 or more numbers. Let's say we want to find the LCM of 12a squared b and 8ac. Okay, remember what a monomial is. A monomial is a number, a variable, or a product of numbers or variables. Okay, so remember what a monomial is. It's going to always pop out in future lessons. So 12a squared b and 8ac. Let's find the LCM. First, let's get the prime factorization of 12. 2 times 2 times 3. Expand a squared to be a times a, and simply copy down b because it's b to the first power. Find the prime factors of 8. 2 times 2 times 2. Okay, and simply write down a and c since they're both a to the their exponent is 1. And then circle our common factors. That's a common factor. That's a common factor. This is another common factor. And that's about it. Okay? We'll bring these common factors down. So you now have, I'll put it on the side here. Okay? It'll be 2 times 2 times a. Now if I ask you what is the GCF of those two expressions, the answer would be 4a. 2 times 2 times a. It'll give you 4a. That'll be the GCF, but it's not. We're not looking for the GCF. We're looking for the LCM. So what do we do next? Okay, so we get the factors that are not in common with the other number, which is 2, and then write it down there. Bring it down as well. That 3 as well. Okay, that another a. Okay, this b. And this c. So if I multiply all of them, end up with 2 times 2 times 2 times 3, which is 24. A times a is a squared, and you have b and c. So the LCM, okay, of 12a squared and 8ac would be 24a squared bc. Okay? Okay, another way to compare fractions is to write them with the same denominator. While any common denominator could be used, the least common multiple of the denominators or the least common denominators is usually the most convenient to use. Okay, so we can use any common denominator, but the LCD or the least common denominator is the most convenient to use. And if you notice, the LCD is the same as the LCM. So the LCD is just trying to find the least common multiple of your denominators. Okay, so let's find out example 3 and how to compare fractions. Which is greater, 5 over 6 or 7 over 9? So we get the LCM of 6 and 9. So getting the LCM of 6 and 9, we have 2 times 3 as the prime factors of 6, and 3 times 3 as the prime factors of 9. Okay? We circle the 3 as common. Okay, so we bring this down once. So you have that 3. And then the 2 doesn't have any common factor. bring that down as well, and this 3 doesn't, bring that down as well. So you multiply all of them. The LCM of 6 and 9 is 18. Okay, so the next step is find equivalent fractions with 18 as a common denominator. Okay, so since the LCM of 6 and 9 is 18, we make this our LCD. And we get the original fraction, which is 5 over 6. Okay, and we equate it to a fraction with a denominator of 18. So all we need to do is ask ourselves, what did we do to make, what operation, okay, would make 6 to 18? And that would be multiplying it by 3. And since you multiplied your denominator by 3, you need to multiply your numerator by 3 as well. Why? Because if you multiply 5 over 6, okay, times 3 over 3, 3 over 3 is the same as 1. So if I multiply 5 over 6 by 1, it will remain 5 over 6. So multiplying it by 3 over 3 will not change the fraction. It will just rename the fraction. Okay? So what happens now is that we have the value of that circle right over there would be 15. 5 over 6 is equal to 15 over 18. And same thing here. Multiply 9 by 2 to get to 18. You need to do that with the numerator as well. And you get your equivalent fraction as 14 over 18. Okay? And we start comparing, since all the denominators have, since all the fractions now have the same denominator, we can simply compare the numerators. 15 over 18 is greater than 14 over 18, because 15 obviously is greater than 15. So, 15 is greater than 14, so 5 over 6 is greater than 7 over 9. Okay? Lastly, connection to algebra. You can also find the LCT for algebraic fractions with different denominators. Okay? Let's find the prime factorization of, let's factor completely 6k squared. So this is 2 times 3, the prime factors of 6, and expand k to be 6k times k. 8km, prime factors of 8 are 2 times 2 times 2, and km. Okay? It's like before, we circle our common factors. Okay? Circle our common factors. So if you notice, if I simply bring down 2 and k, I can find my GCF, which is 2k. And since we're not looking for the GCF, we go one step further. Okay, we get our 2, write it down here. We get our k, right down there, the ones I've circled. This one does not have a partner. These two don't have partners. And the k and the m don't have partners as well. And we multiply all of them. So 2 times 3 is 6, times 4 is 24, times k is k squared. So this is 24 k squared m would be the LCM. Okay? So if that's the LCM, 24k squared, then the LCD of 6 or 5 over 6k squared, and 3 over 8km is 24k squared m. And that's the end of the lesson. Thank you for watching.